do a little check?
Sure. Why don't I get started? So what I want to do today is to sort of use the math we did last time to derive some demand curves, just to remind you where we are in the course. The start of the course was thinking about supply and demand and the two curves interacting with each other to find equilibrium, right? And what we've been doing since then in the last couple of classes is to try to say, where does demand come from, right? So demand is coming from individual consumers who are choosing to maximize their utility, facing some constraints given by prices and incomes. Once we're done with demand side of things, which will be in a couple of classes, we'll move on to the supply side of things, which is thinking about the decisions for firms. Okay? So today we're going to derive demand curves for the example we've been playing with a couple of times. I'll then think about how demand curves shift around as income shifts around. And then I'll talk about why and when demand curves are downward sloping by decomposing the effect of a change in price into a change in income and a substitution effect. Okay? So by the end of class, we should be through all that stuff. Okay, so let me remind you what we did at the end of last class. We spent a whole bunch of time thinking through one example. Another example I showed you at the very end of class was this utility function, u is a to the 1/3, b to the 2/3. If we sort of do a symbolic derivation for that problem, what we find by setting the marginal rate of substitution equal to the marginal rate of transformation, we get -1/2 b over a is equal to -pa over pb. Right? If we use that together with the budget constraint that the total amount that they spend is equal to income, then we can derive the optimum bundle a and b for any given prices and income. Right? Then we could use that to show how the quantity of a and b demanded shifts around as I change prices and or incomes. Okay? We're going to do that today with a new example, but I'll come back to this one in just a couple of minutes, and we'll see the same effects a couple of times. All right. So let's go and look at this example. This is the example we did a few classes ago, where we have utility function over root beer and pizza being the square root of b times p, and we have some fixed prices of these things. And what we derived last time, when we did this last time, was that the optimum bundle is is 6.3. Okay? What I want to do this time, today, is to do the math that I've got there for this particular problem to derive the general bundle and then think about how the bundle moves around as I change prices and incomes. So to do that, let me write down the equation that says the marginal rate of substitution equals the marginal rate of transformation. So to compute the marginal rate of substitution, let's do the negative of the marginal rate of substitution so that I've got the marginal utility of b over the marginal utility of p. Okay. I'm going to do this thinking of root beer as being on the horizontal axis, so I'm putting MUB on top, right, and pizza on the vertical axis, MUP on the bottom. Marginal utility of b is 1/2 times the square root of p over b. And the marginal utility of p is 1/2 times the square root of b over p. Put the two together, and I get that this is equal to p over b. Right, that tells me that as pizza goes up and root beer goes down, that's going to make the marginal rate of substitution go up. That's going to make the curve steeper. Okay? I'm going to set this equal to the price of root beer over the price of pizza, which here is going to be, well, I'll do this more generally. Okay? Set those two things equal to each other. That implies that the price pizza times the price of pizza. That should be the price of root beer over the price of pizza. Pizza times the price of pizza equals root beer times the price of root beer. Okay? And I just want to point out something which is going to pop up a whole bunch whenever we use utility functions that look like this. When you get to this point, you see that the price times the quantity equals the price times the quantity for these two things. What this is telling me is that the total spending on pizza is equal to the total spending on root beer. Okay? That's not a coincidence. It's coming from the fact that this is sort of pizza and root beer are coming in. You can write this as b to the 1/2, p to the 1/2. And what those exponents are telling me is basically, I can read in a Cobb-Douglas case like this, in a utility function like this, I can read off the coefficients what fraction of my income I'm going to spend on the two goods. The ratio of these exponents, when they have this product of things to powers form called Cobb-Douglas, the ratio of exponents is going to be the ratio of spending. Okay, so I've got this derived here. I'm then going to take that condition and plug it back into the budget constraint. So the budget constraint is the total spending on pizza plus the total spending on root beer has to equal my income. Since this thing is equal to that thing by the tangency condition, this tells me that the amount of pizza I'm going to choose is y over 2 times the price of pizza. Or another way of saying the same thing is I'm going to spend half my money on pizza. And similarly, I'm going to spend half my money on root beer. Okay? So let's just go back to the example. Let's see. What we showed here is that the optimal thing to do is to buy 6 and 3. Right? That's because we're going to spend half of our $24 on each of the two goods. If we spend $12 on pizza, that's going to let us get 3 pizzas. If we spend $12 on root beer, we'll get 6 root beers. There's our 0.63. Okay? So this coincides with the example we've done before. Now what I would like to do is to use this general thing to think about what demand curves look like. So notice, if I pick a given income, let me fix the income at 24. If I pick a given income, this equation here tells me for any given price of pizza how many units of pizza I'm going to demand. Right? It's also going to tell me for any given price of root beer how much root beer I'm going to demand. For this particular utility function, it turns out that the price of root beer doesn't show up in this equation and the price of pizza doesn't show up in this equation. They could in general, right? The price of one thing could affect the quantity demanded of the other. They don't happen to here because of the particular utility function I've chosen, but that's sort of a special case. So let's go and sort of use this qualitatively to derive a demand curve. Okay, so here's what we've just derived. For this particular case, if you've got a budget constraint corresponding to $24 and a price of 6 and 3, then the optimum happens at 6 root beers. Sorry, at an optimum of 6 and 3. The optimum's happening for these prices at 6 root beers and 3 pizzas. What happens if the price of pizza goes up? Well, if the price of pizza goes up to $3, sorry, the price of root beer goes up. If the price of root beer goes up to $3, right, then it's going to rotate the budget constraint in. I can no longer afford 12 root beers if I spend all my money on root beers. I can only afford 8. It's going to shift that intercept in without changing the vertical intercept. It's going to rotate the budget constraint like it's shown here. And I can use my general demand curve here to derive what the new optimum is. Right? The price of root beer hasn't changed. Sorry, the price of pizza hasn't changed, so my pizza quantity is not going to change. It's going to stay at 3. The quantity of root beer is going to change because I'm now going to have 24 over 2 times 3 instead of 2 times 2, or 24 over 6, so it's going to move in to 4. Right, so I move from having 6 root beers to 4 root beers without changing my pizzas in response to this price change. Now, this shouldn't be surprising, right? Like, what happens when the price of something goes up? Should be that the quantity demanded goes down. Okay? Similarly, if we thought about letting the price of root beer go down, so it's only $1.50 now, so that I can afford to buy as many as 16 root beers if I spent all my money on it, then my quantity of root beer demanded should go up, and you can calculate that it should go up in particular to being 8. Sound good? Right, I'm spending $12 on root beer still. Now they cost $1.50, so I get 8 rupees when I'm at that optimum point. Now what I want to do is take this, I want to do a couple things with it. What I want to do is show you can do this exact same exercise and use it to derive point by point what the demand curve looks like. Okay, so do the exact same exercise. Start with one budget constraint. Okay? That gives you one, so start with a budget constraint corresponding to a single price of root beer. In the diagram below the top diagram, copy the horizontal axis, but change the vertical axis from being about pizza to being about the price of root beer. Pick any given price, like 2. Use the top diagram to find the optimum. That's at the point 6.3. And then drop a dashed line down and plot the point corresponding to that quantity of root beer and that price of root beer in the lower diagram. Increase the price of root beer. We find a new optimum, and we have a new price in the bottom diagram. Again, drop the coordinate down, correlate it with the price of root beer in that new price, and we'll get a new point corresponding to another point on the demand curve. Do the same thing for a lower price, we get a third point. Keep doing this for all the prices, connect the dots. This is our root beer demand curve. Okay? Notice in this case, it's not linear. Right? In this particular case, the root beer demand curve is 24 over 2 PB, so it's 12 over PB, so it's actually a rectangular hyperbola rather than a line, right? But it's a downward sloping demand curve that we've fully derived. Sound good? In other words, consumer choice is how we derive a consumer's demand curve. Let me just flag one quick thing about that. This is how we derive a consumer's demand curve. What we started the class with when we did supply-demand diagrams was not a consumer's demand curve. What we started the class with when we did supply and demand curves were the market demand curves. Right? The total quantity demanded in the market and the total supply in the market are what intersect to find the price. So how would you go from this sort of a derivation of an individual consumer's demand curve to a market demand curve? Well, qualitatively, you would imagine the market consists of a whole bunch of different individuals who potentially have different utility functions and potentially have different incomes. Right? And then you would say, at any given set of prices, well, let's say fix the price of pizza and think about changing the price of root beer. At any given price of root beer, each consumer will solve a consumer choice problem, which will yield a quantity of root beer that they demand. We'll then add up across all the consumers to find the total quantity demanded in the market. Graphically, what that'll correspond with is doing a picture like this for each consumer and then adding the bottom diagrams horizontally. So that at each given price, we figure out the quantity for each of the consumers and add them up horizontally to get the market demand. So we now have all the tools we need to know where demand curves come from, okay? And to think a little bit about why they might be downward sloping, or why in particular they're downward sloping. Okay, let me just say a few things about these demand curves. If I think about varying the price and draw the bottom diagram, what I get is the demand curve. But another diagram that economists sometimes like to play with is the one up top, where I think about varying the price and connecting the dots in that top diagram. The name for that curve is the price consumption curve. Okay? Think of that as how does the consumption bundle evolve as the price changes. You could do a very similar demand curve and a very similar price consumption curve for root beer. If you for pizza. If you did, it would be vertical. You'd fix the amount of root beer you're buying, and as you change the price of pizza, you'd get more or less pizza. Okay? It's a little harder with this diagram to use the same diagrammatic approach to deriving the pizza demand curve because the quantity in a demand curve wants to go on the horizontal axis, and pizza's on the wrong axis for that. So to do that, you just sort of want to flip the axes and then do the same derivation. Okay, what do you notice about this price consumption curve? Well, this is actually kind of an unusual one. This is a price consumption curve with the property that it's perfectly horizontal. That's coming from the fact that the demand for pizza that we derived here doesn't depend on the price of root beer. So as I change the price of root beer, the amount of pizza this particular person purchases doesn't change. That is known, the sort of formal terminology for that is that we say there is a zero cross elasticity of demand. Let me write that down. Write it down over here. So the cross elasticity of demand is defined to be the percentage change in the quantity of one good divided by the percentage change in the price of a second good. Okay? This is just like you define the elasticity of demand, except that the good on the top is different from the price on the bottom. That's why it's called a cross elasticity rather than a regular price elasticity. Okay? Here, this cross elasticity is exactly 0 because the percentage change in quantity of pizza as I change the price of root beer is 0 and vice versa. There's a terminology for what happens when this thing isn't always 0. It's going to happen to be 0 when I use this Cobb-Douglas utility function. Right? This particular utility function was giving us this, but lots of utility functions would give us different answers. And in fact, we think that most goods won't have a 0 cross elasticity. So let me give some extreme examples. Let's take an extreme example of left shoes and right shoes, and suppose they get priced individually. Okay? But they're perfect complements to each other. When the price of left shoes goes up, what happens to the quantity demanded of right shoes? So if the price of left shoes goes up, what I expect to happen is people will go and say, well, shoes as a pair are more expensive than they used to be, so I'll buy fewer shoes overall. So what I'll get is the price of left shoes going up and the overall numbers of shoes going down by the law of demand. So I'll have a negative quantity and a positive price change. A positive price change will reduce the overall quantity demanded. These things are complements, right? So if this thing is less than 0, we say that they're complements. If the price of peanut butter goes up, what happens to the demand for jelly? Peanut butter gets more expensive, quantity of jelly demand is going to go down, right? So one of these is going to be positive, one of these is going to be negative. Those are complements to each other, right? Peanut butter and jelly go together. Right? At the other extreme, you might think about substitutes, right? Things that are perfect, or things that are close to substitutable for each other, right? So the price of sliced ham goes up. What happens to the quantity demanded of sliced turkey? Well, if ham's more expensive, then some subset of people who are going and thinking they'd buy ham switch to buying turkey, right? So we expect the price of ham to be positively related to the quantity of turkey. All right, greater than 0 means substitutes. Sound good? And this is just saying for this particular problem, it happens to be that pizza and root beer are neither substitutes nor complements. They're exactly on the line in between. Okay? That probably suggests, actually, since I think of pizza and root beer probably as being complements to each other, this is probably not the right utility function for most people for modeling root beer and pizza. Right? It happens to be a nice functional form for playing with it, but that doesn't mean it's realistic. Okay. Next thing I want to do is, using the exact same example, I want to think about different shifts. Instead of thinking about a price change, I want to think about what changes when income moves around. Okay? I can do that just as easily because I have the quantity demanded of the two goods as a function of the income as well as the prices. So if I hold prices fixed and shifts income, I can find new answers. So here's the original optimum again. What happens when income goes up? Let's say it goes up by 1/3. Well, an income shift is a parallel shift of the budget line. It doesn't change the ratio of prices, so it doesn't change the slope of the budget line. But I can now afford more root beer and more pizza. Right? The whole thing shifts out in a parallel way. And it turns out that the new optimum you can get easily shows you that the new optimal bundle has 8 root beers and 4 pizzas. In other words, the quantity of pizza has gone up by 1/3, and the quantity of root beer has also gone up by 1/3. Sound good? In other words, the quantity of the two goods has increased in proportion to the amount of income I have. Right? And that's sort of obvious if you look at this. If I were to double income, what would happen to the bundle? Well, I'd double P and I'd double B. If I multiplied Y by 1.1 and I multiplied Y by 1.1, I'd get P and B both going up by 1.1. In other words, a 10% increase causes a 10% increase in each of the goods. Sound good? Now, I could do a couple of, and similarly with a decrease in income, I'm going to buy less of both of the goods. Now, I could do a very similar thing as I did last time for trying to derive the demand curve. But notice that when I do this, I'm not actually deriving the demand curve this time because I'm not changing the price. So even if I put the price on the vertical axis, I wouldn't get a movement along the demand curve when I change the income. What I'd get instead is a shift of the demand curve. What this would be saying is, now that income is higher, at any given price, I'm going to want more than before. right? That manifests itself as a right or leftward shift, depending on whether income goes up or down. Sound good? To say it another way, if we're thinking about a demand curve as lying in the space of root beer and the price of root beer on the two axes, then a change in income is a shift of the demand curve rather than a movement along the demand curve. Economists are a little bit sloppy when using this. So like in an intro class like this, we'll typically refer to the demand curve as being the relationship between the price and quantity, holding everything constant. In other words, a picture like this. So we'll think of this as a shift of the demand curve. But sometimes we'll refer to this thing as the demand curve as a function of all the prices and incomes, in which case, this would be a movement along the demand curve. It's not a change of tastes. It's just that it's a change of incomes. So you'll see both those languages used. But I'll try to be careful to just say the demand curve is the price-quantity relationship. When you think of it that way, a change in income is a shift of the demand curve. Okay? But we could do a different, okay. So two other curves that are useful to know the names of in this space. This first one is called the income consumption curve. This is just like the price consumption curve, except that instead of prices changing, its income's changing. And because of this proportionality in this particular problem, this price consumption curve is a straight line through the origin. I think about the optimal bundles for different incomes. I connect the dots, right? And because of this proportionality, as income goes up, the quantity of each of the goods is going up proportionally. That means I'm going to be moving up and to the right, at a constant slope. The ratio of root beer to pizza is going to stay the same. Good. I could also, and this is the next diagram, I could also do the analog of the derivation of a different analog of the derivation of the demand curve. So the way we thought about the demand curve is we put the thing we're varying on the vertical axis down below in the diagram, and then we plot the locus of equilibria quantities we get correlated with that thing that I am changing. So if I do that here, I get a picture that looks like this with income on the axis, because that's the thing that's changing. Right? And what this is simply saying is that as income goes up, root beer goes up proportionally. It's a straight line with a slope equal to 1 over 2p, or 1 over 2 times the price. Sound good? The name for this thing is the Engel curve, for Karl Marx's co-author. Right. So there are two Engel curves, one for each of the two goods. They're very closely related to this income consumption curve, except that in the Engel curve, I make the income variation explicit, as opposed to in the top diagram where the income variation is implicit. It's not on one of the axes, right? It's the thing that's shifting around, moving me along the curve, right? Whereas down here, I actually see the thing that is varying the income on the vertical axis. Okay. Just like I could think about a cross-elasticity of demand, I can define oh, I should have kept that. I can define an income elasticity of demand. So the income elasticity of demand is xi is defined to be the percentage change in quantity over the percentage change in income. It's how does my quantity respond to changes in income? Okay. So the percentage change in quantity, the percentage change in income, and I just want to think about this problem here. So what is this number for this problem? What is the income elasticity of demand for this problem? It's 1, right? And you can think of that because a 1 percentage change in income causes a 1 percentage change in the quantity, right? So elasticities, you remember from the elasticity of demand way back when, the elasticity of demands are how does the quantity change in response to prices? And we said this thing is closely related, but not the same thing as the slope of the demand curve. Very similarly, the income elasticity of demand is closely related to the slope of the Engel curve, but not exactly the same thing. But in this particular case, I mean, in this particular case, it's sort of easy to, well, I don't want to say it. If I instead redid this bottom plot on a log-log scale, then the slope of that thing would be exactly the income elasticity of demand. Okay? Here, for this problem, because everything is proportional, this happens to be 1. But that's a special case corresponding to this utility function and won't in general be the case. Okay? Let me say a couple things about it. So first, the fact that this number is positive means that this good is what's called a normal good. Normal goods are goods with the property that as I get richer, I buy more of them. Okay? I think this is sort of ordinary. If you think about cappuccinos or sushi or something like that, as your income goes up, you're going to tend to buy more of those things. Clothes would be another good example, right? As income goes up, you buy more of them and you spend more money on them. Sound reasonable? Right? That's not true of all goods, though. It's true of most goods, but it's not true of all goods. So there are some goods out there that are what are known as inferior goods. An inferior good is still a good. You like them. It's better to have it than to not have it. It's not violating monotonicity. It's still a good. Right? It's just that it's something that you buy less of as you get richer. So a good example would be a staple food like potatoes. Right? You're not going to stop buying potatoes. You're still going to buy potatoes. And having more potatoes will be better. But as you get richer, maybe you buy fewer potatoes and more meat. Right? Or cabbages. Right? As you get richer, you buy less of them. So it is perfectly possible to have this have a negative sign, and that's known as an inferior good. Okay? Economists further break down normal goods into what are known as luxuries and necessities. This is just sort of a terminological thing. But if you think of that thing being, if you think of xi as being bigger than 1, right? That says as my income goes up, I spend more than proportionally on this good. So a good example might be going out to fancy meals, right? You don't do too much of that when you have low income, but as you have some disposable income, as you can take care of all of your other needs and you have more disposable income, you might spend a large share of that additional income on going out to fancy meals. That would make that a luxury good. Diamonds, jewelry, another good example of luxury goods. Okay? Other goods known as necessities, so this is luxury. Other goods, less than 1, are known as necessities. Right? And necessities are goods for which you buy them when you're poor, and you still buy a little bit more as you get richer, but not proportionally so. So meals at home might be an example. You might no, that's not a good example. Food would be a good example of that, right? You might spend a lower proportion of your money on food as you get richer. Okay? Might. Depends a little bit. Now, the difference between luxuries and necessities is a little bit, sometimes it's a useful distinction, sometimes it's not. I'm mainly just showing you this to sort of give you the terminology for what they mean. But whether it's a luxury or necessity depends a little bit on how you define it, right? So if you think of it as food in general, then it's plausibly a necessity. If you think of it as, or you think of it as food at home, it's probably a necessity. If you think of it as food out in fancy restaurants, that's probably a luxury. But if you think of it as food as a whole, it's not so clear. In some ranges, it might be a necessity. In some ranges, it might be a luxury. Okay. Good. That's what I wanted to say about the relationship between income and demand. The last thing I want to do today, in the last 20 minutes or so, is I want to think about the income and substitution effects of a change in prices. In other words, I want to think about why the demand curve is downward sloping. So let me start with a simple example of a normal good. Going back to this example we had before with root beer and pizza. Give me a set of prices, give me an income, give me a utility function, and I can find the optimum. And the optimum here happens to be 6.3. And then I can ask, what happens when the price goes up? Okay? When the price goes up to $3, what we found is that the new optimum becomes 4.3 instead of 6.3. In other words, the quantity demanded goes down. Okay? Why did the quantity demanded go down? This is what we expected, right? This is just saying that the demand curve is downward sloping. This is what we expected. When the price of root beer goes up, we're going to buy less of it. But why? Actually, you can think of there as being two distinct reasons why I expect the quantity of root beer to go down when the price goes up. The first reason is that when the price of root beer goes up, it's a less good deal than it used to be. Right? Relatively speaking, root beer is a worse deal, and pizza is a relatively better deal. So I would expect to find a desire to substitute away from the now worse deal root beer towards the better deal pizza. Okay? That's just about it being a better deal. But there's a second effect here, which is when the price of root beer goes up, my budget constraint is farther in than before. I can't reach the same level of utility before. I'm effectively poorer than I used to be. I can't afford as much stuff as before. If I have less buying power, then what am I going to do? I have to buy less of something, and if both goods are normal goods, then when I have less buying power, I'm going to buy less of all of them. Right? When I'm effectively poorer, I'm going to buy less of both things. I think there being two reasons why the demand for root beer is going to go down when the price goes up. One is I'm substituting away from root beer because it's a less good deal, and the other is I'm poorer, so I'm buying less root beer. I'm buying less of everything, including root beer. What I want to do is show you how we're going to, for this class, do the decomposition into those two effects. And there's a payoff for doing this at the end. Okay. So what I would like to do is separate these two effects from each other. I want to separate this income effect, this well-being effect, from this relative prices effect. How could I measure whether I am poorer or not? What's the right measure of whether this change makes me poorer or not? It does, but what's the right measure of how much? Well, one way to think about it would be I can't afford the same happiness level I had before. Right? The right measure of well-being is utility here. Right? So if I wanted to say, imagine the prices changed, but I wasn't poorer, what you'd want is to imagine that the prices changed, but I somehow managed to stay on the same indifference curve, holding my utility constant. Or another way to say it is, this price change made me worse off, right? How much worse off did it make me? One way of answering that question is to say, well, after the price change, how much money would you have to give me to compensate me for the fact that the prices are now higher, to leave me as well off as I was before? The answer to that question you could find by hypothetically shifting the budget constraint out by giving me more income until I get back to my original indifference curve. But notice when I've gotten back to my original indifference curve at the point B, I'm not at the same, I don't want to be at A anymore. Right? The amount of money you have to give me to get me back to the same level of utility is less than the amount of money you'd need to give me to get me back to point A. Right? Because I hit that sort of tangency B before that new dash budget constraint goes through point A. Right? So here's a way to think about it. I'm going to decompose the movement from A to C into a movement from A to B, and then a movement from B to C. In the movement from A to B, the relative prices have changed, but I haven't gotten better or worse off. Right? This is a pure relative price change. We call that the substitution effect. I'm substituting away from the now more expensive root beer and towards the now relatively cheaper pizza. Good? And the second effect, the movement from B to C, is, but I'm poorer than I was before too. My purchasing power has gone down, and that income difference between the dashed line and the blue line is a measurement of how much poorer I am. Right? Particularly the measure of how much you would have had to compensate me to make me no worse off as a result of the price change. So we can think of the two reasons why the demand curve are downward sloping is coming out of this decomposition. The overall effect of the price change was the movement from A to C. The movement from A to B, that is a change in relative prices at constant utility, is called the substitution effect. It causes me to go down to about 4.9. You can actually compute what it is, but it goes down to about 4.9. It goes down to about 4.9 units of root beer. And then in addition, I'm effectively poorer. I've lost some money. So I'm going down and to the left from point B to point C, losing my amount of root beer. Right, so there are two reasons I have less root beer, an income effect and a substitution effect. And they're working in the same direction here, both of which make the demand curve downward sloping. Sound good? In this diagram, you can see, even if I didn't derive it from something like this, if I just do the diagram, you can see from this diagram whether root beer is a normal good and whether pizza is a normal good by looking at the movement from B to C. What we see in the movement from B to C is that when income went down, I consumed less of both goods. Right? That says when income goes down, I buy less. That means this elasticity is going to be a positive number, negative over negative, which means these are normal goods. Right? As income goes up, I buy more. As income goes down, I buy less. When they're a normal good, the income and substitution effect of a price change move in the same direction, and the net effect is that I'm buying less root beer. Before I think about the case of an inferior good, which is, I think, it turns out to be pretty interesting, I just want to point out that the movement from B to C here is determined by the fact that root beer and pizza are both normal goods. If root beer were an inferior good, then when I had income fall, it would actually make me buy more root beer. What that means is that the income effect on root beer or the income effect on pizza is actually ambiguous from a theoretical perspective. I need to have a utility function to figure out which direction it goes. But the substitution effect is not ambiguous. The substitution effect always has the same sign. A rise in price always makes me, by the substitution effect, have less root beer, consume less root beer. Right? There are a couple ways of seeing that. And the easiest is just to say graphically, when the price of root beer goes up, my new budget constraint is going to be steeper. If I'm going to move along the indifference curve to a new point of tangency with a steeper budget line like that dashed one, it has to be at a point where the indifference curve is steeper than the original point. Point B has to have a steeper slope than point A. And if indifference curves are bowed to the origin, right, then the only points where the indifference curve is steeper than the original point are up and to the left. So when the budget constraint gets steeper, but I hold my utility fixed, I have to move up and to the left. Right? That tells me the direction of the substitution effect. Okay? And it's unambiguous. It always moves in this direction. What if the price of pizza went down? Actually, you'd have the exact same substitution effect in that case qualitatively. If the price of pizza went down, the budget line would get steeper. Right? And I would again substitute towards pizza and away from root beer. The story for it might be a little different. I'm now substituting for pizza because it's cheaper as opposed to substituting away from root beer because it's more expensive. But from a substitution effect perspective, all that really matters is the ratio of prices because you're, by assumption, staying on the same indifference curve. Okay? There's one other way to say the same thing. So let me think about this in sort of 5 steps, why the substitution effect has to be negative. Try to give some economic intuition for it. This is related to the idea that indifference curves have to be bowed towards the origin. So we know that the substitution effect is going to move me from one tangency to another. Right? And I know that the ratio of prices has gone up, so that the new point's got to be steeper. What that means is the ratio of marginal utilities is going to have to go up. The marginal utility of B is going to have to go up, or the marginal utility of pizza is going to have to go down. How could you make the marginal utility of root beer go up? Have less root beer. If marginal utility is decreasing, right, then the only way to make the marginal value of additional amounts of root beer higher is to start with less root beer. So the only way to make the marginal utility of root beer go up is to have less root beer. The only way to make the marginal utility of pizza go down is to have more pizza. So if I need to make that ratio of marginal utilities go up to match the new price ratio, the new marginal rate of transformation, I need some combination of less root beer and more pizza. Right? And the only things on the same indifference curve that have less root beer and more pizza are up and to the left. Right? In some sense, that's saying up and to the left. It's just another way of saying the same thing that the graphical stuff is telling us. All right. Good. So now let's. This is the slide I put up. I put up from the last time. I guess this is another example of the same thing. So the example we did last time, very quickly at the end of class, was to derive for the example I had up at the beginning, what happens when the price of apple juice goes down. The price of A went down from 40 to 5. Right? That rotates the budget constraint out from BC1 to BC3. And the net effect of that was a horizontal movement in the quantity of apple juice without changing the price, without changing the quantity of blueberries. The middle example that I had that last time, you can think of as exactly the choice that finds the substitution and income effect decomposition. Because by construction, that change in that BC2 corresponds to the new prices, but a lower income. And I've chosen that lower income, 360 in that example, so that the utility that I get from BC2 is exactly the same as the utility I get from BC1. I think it was 24 root 10, if I remember right. Right? So if I think of the movement, the effect of the change in prices as the movement from the blue to the green, I can decompose it into a movement along the indifference curve to a now shallower sloped point, corresponding to the new ratio of prices, plus I'm getting richer by $360 in this case, a movement from the red to the green. In other words, that first movement from 1 to 2 can be thought of as a substitution effect, and the second movement from 2 to 3 can be thought of as the income effect associated with it. Both effects are pushing me to buy more apple juice. Demand curve is downward sloping for apple juice because of both the income and substitution effects, both of which make me buy more apple juice when the price of apple juice goes down, because apple juice is the normal good. Okay, let's do the same exercise now for an inferior good. Okay, let's have two goods, potatoes and steak. I should point out, if there are two goods in the economy, they can't both be inferior. There needs to be at least one normal good, and if there are only two goods, that means one of the two has to be normal. Right? The reason that at least one of the goods has to be normal is because of monotonicity. When you get more money, you have to spend it on something. Right? Monotonicity ensures that I'm going to spend all my money on goods. More stuff is better, so if I get more money, I'm going to spend it all. If all goods were inferior, then if I get more money, I would be spending less on everything, because I'd be buying less of everything, right? Which would mean I'm not spending all my money anymore. So it cannot be the case that all of the goods are inferior. At least one of the goods has to be normal. So here I'm going to draw this picture with potatoes being an inferior good. That is going to ensure that steak is a normal good. Okay? I start at point A, and then I raise the price of potatoes. Let me decompose that into an income and a substitution effect. The substitution effect says, well, potatoes are a less good deal than before, so if I held my utility fixed, I would move up and to the left along the indifference curve from A to B. If you gave me enough money to compensate me for this so I can still afford the same level of utilities before, my new bundle would be more steak heavy and less potato heavy, because steak is a better deal relative to potatoes relative to how it used to be. Okay? I substitute towards steak and away from potatoes. The second effect is an income effect. I'm effectively poorer than I was before. I didn't get enough money to compensate me for this change. In fact, I can think of it as I got the money and then the money was taken away, so I'm effectively taking money away from me. I'm effectively poorer. When I get poorer, what happens to my quantity of potatoes demanded? Well, if it were a normal good, it would go down, but because it's an inferior good, when I get poorer, I buy more of it. Right? If you had a sudden income shock and couldn't afford to go out to eat as much as you currently do, you'd eat more ramen in your room. Right? Income going down could make you could make you forced to buy things that you think are inferior but still satisfy your needs. Right? That's what's going on here. When I get poorer, I buy more potatoes and much less steak. That makes steak a normal good, right? Because I'm poorer and I'm buying a lot less of it. In fact, it's very normal, and potatoes here are inferior. Notice that in this particular case for potatoes, the demand curve is still downward sloping. Right? The price of potatoes went up, right? Moving from BC1 to BC2, the price of potatoes went up. And the net effect is that my quantity of potatoes went down. That's how it should be, right? That's how demand curves are supposed to look. But notice here that, in fact, it's not obvious if when a good is inferior, it's not, in fact, obvious that when the price of a good goes up, it'll make the quantity of that good go down. We have two offsetting effects. On the one hand, when the price goes up, the substitution effect says I substitute away from it towards other goods. On the other hand, when the price goes up, I'm poorer. And if it's an inferior good, I'm going to buy more of it as a result. If the income effect were bigger than the substitution effect, the net effect would be pointing to the right, and I would have an upward sloping demand curve. Right? The point of this is to say it is all well and good and totally intuitive to start an intro micro class by saying we're going to look at supply and demand curves slope down, supply curves slope up, and to tell a story about why that's true. But actually, when you get down into the where do demand curves come from, consumers are maximizing utility, it's actually theoretically ambiguous for a subset of goods whether demand curves are in fact downward sloping. There was a huge debate in economics before data was really available about whether in practice you could have downward sloping demand curves. One of the solutions by the way, to solving this problem was to redefine what we mean by the demand curve to be what's called the Hicksian demand curve, which is to say, we'll define the demand curve holding utility constant rather than holding income constant. If you hold utility constant, then you're stripping out the income effect. You're just doing the substitution effect, and the substitution effect always is downward sloping, right? It's always going in the right direction, right? So that's sort of one theoretical response. But of course, it's interesting that the thing that matters for actually finding equilibrium in real markets is not that demand curve. It's the actual demand curve, what happens holding incomes fixed as the prices change. And it's ambiguous what the slope of that curve is. It could, in fact, be upward sloping. Let me give an example. So here's a story for how you could get an upward sloping demand curve. They're really hard to find in practice. But the sort of story you can tell for how it could happen in practice is the following. Imagine someone who's a subsistence worker. They're barely making enough money to buy the cheapest food they can and fill their bellies and meet their caloric needs. Right? They're extremely poor. And imagine they're spending all of their money on potatoes. Right? Basically, all they earn, they go to potatoes, and they're spending all their money on potatoes because that's barely enough food to fill up their bellies and to give them the calories they need to keep going day to day. And now imagine someone comes in and gives them a subsidy and makes potatoes cheaper. How are they going to respond to that? Well, think of it in a couple steps. Imagine that they bought the same number of potatoes as they had formerly bought, right? Enough to meet their caloric needs. Now that they're being subsidized for potatoes, they have some leftover money. What are they going to do with that leftover money? Well, a natural thing to do is to buy some higher quality foods, or some other foods at least, some vegetables or some beans or some chicken or something along those lines, right? Well, when you spend that additional money on that additional food, those other foods are now meeting some of your caloric needs, which means that you can get away with buying fewer potatoes than before and still meet your caloric needs, and then actually use the saved money from those potatoes by even a little bit more of the higher quality food. So this is a case where the price of potatoes has gone down due to the subsidy, and the net effect is that we're actually buying less potatoes than before. In other words, an upward sloping demand curve. Lower prices lead to lower quantities. And this is not just a theoretical curiosity. There's a 2008 field experiment that was done. There have been a couple of them, but the field experiment, I believe, was done in China, in a village that subsisted basically on millet. And they came in and picked a random subset of villages subsisting on millet, and they randomly gave subsidies to some of the villages and not to some of the others. And they looked at whether looked at the quantity of millet purchased in those two types of villages. Right? What they found was interesting. What they found is that among the relatively well-off people, they were still pretty poor villages, but among the relatively well-off people in those villages, you saw a normal downward-sloping demand curve. But among the poorest of the poor in those villages, you saw an upward-sloping demand curve. You saw exactly the behavior I've just described, that when the subsidy is put in, they can afford to buy other goods now, and they end up buying less millet, less of the staple good, and more of other things. Okay? So this is more than a theoretical curiosity. It is, in fact, possible to have a demand curve that slopes the wrong direction. But they're extremely unusual, and we're not going to see them very often in practice. I should say just a couple things about that. So the nice thing about that paper, and I'm happy to send you a copy of that paper or a link to that paper if you want to see it. One of the nice things about that is it's really done in an experimental way. Right? And economists have been moving in this direction as much as possible. It's an expensive experiment to run, but it's done actually with randomization in a control group. Right? There was the name of these goods with upward sloping demand curves that are extremely rare, it's called a Giffen good, after the guy who first posited that they could exist in the context of the potato famine in Ireland. Right? So in the potato famine, he argued the prices of potatoes have gone up, but because that makes everyone, but because it's hard to afford to feed yourself now that prices of potatoes have gone up, people actually end up buying more potatoes to just fill their bellies. Right? That was the argument. The problem with that context is it's not a pure shift in the price. It's not a pure movement along the demand curve, because at the same time, there's probably also shifts of the demand curve itself. For example, a shift of the demand curve from emigration, which was a big thing at that time. Right? So migration of people is going to shift the demand curve. You're not going to be able to perfectly identify whether this is a movement along the demand curve or a shift of the demand curve. In other words, you don't have a causal effect. You only have a correlational effect. Put this up. So big picture, this is the table you want to keep in mind. For a normal good, the income and substitution effects reinforce each other so that the demand curve slopes in the correct direction. For an inferior good, if it's strongly inferior enough, the two effects offset each other, and we can't theoretically sign what the total effect is. for the rest of this course, we'll think about there being a downward sloping demand curve. But it's important to notice that once you actually figure out where the demand curve comes from, it's not, from a theoretical perspective, guaranteed that it's going to downward slope. And I will see you next week.